I'm Marlo from Wild Food UK, out foraging again, and I'm in the field beside my house. This is not your normal Wild Food UK video, and I do apologise about the clickbaity title, but believe me, we do find uranium in our mushrooms. Now, the mushrooms in question are these ones down here. These are our lovely field mushrooms. I've done a whole video on how to ID the field mushroom before, so if you want to know more about this particular species, then please go and have a look at that video. What this video is about is the unseen potential dangers, I suppose, of foraging. Now, just wait for this traffic to go past a bit. There's a few obvious dangers of foraging. Ticks are probably high on the list, and things like giant hogweed are high on the list. Poisoning shouldn't be. If you follow the first rule, the number one rule of foraging, do not eat anything unless you know exactly what it is and that it's edible, then poisoning should just not be an issue. The key word in that sentence is you. Don't trust anyone else. Be sure for yourself before you eat anything wild. But there are unseen dangers as well that come from our roads around us and other industrial places. I'm obviously talking about pollution. That's what this video is all about. It's quite a sciencey video for at least the first 15 to 20 minutes, but if you want to skip the sciencey stuff, then go to about minute 16 or 17, and the summaries are kind of from there onwards. But like I say, this video, it's about pollution. It's about whether it's safe to pick mushrooms like this from beside roads like this. So you'll come back to me at the end of this video and I'll tell you whether I'm taking these mushrooms home for my pot or not.
Okay, hey Giles. I've obviously known you for a very long time, but if you wouldn't mind, could you introduce the viewers to who you are and what you do?
Yeah, hi. So my name's Giles. I'm an analytical chemist. So I've been doing analytical chemistry for quite some time now. Well, I suppose since last millennium. So my main speciality is really mass spectrometry. So this is an analytical technique, and we measure the mass of molecules and atoms in order to work out what they are, and then we can measure the concentrations of them. So it's a very useful technique for monitoring pollution in the environment. So I'm currently working at the University of Manchester, defected into the nuclear physics group. We have a spin-out company where we're trying to commercialize new analytical instrumentation to look for ultra-trace radionuclides. So this is where the Artemis analytical comes in. And what we're doing at the moment, we're screening various different sites for pollution. We're doing home water testing, and our services are available.
Okay, yeah, good stuff. So you are an actual scientist then. Do I need to call you Dr. Edwards for the rest of this conversation, do you think? Or are you all right if I still call you Giles?
You can call me Giles. My son calls me Dr. Daddy.
Dr. Daddy. Oh, fantastic. That's great. I love that. Right. And obviously, I've enlisted your help and the services of your wonderful laboratory to help me gauge something that up until now for me has only really been hearsay. We've always heard as foragers that, you know, you're going to be eating slightly polluted mushrooms in particular if you pick them from the sides of roads, and that has always been largely associated in the foraging world with a family of mushrooms called the Agaricus genus, I suppose, and one particular mushroom called the field mushroom. So what we've done is very tasty, a lovely mushroom. We foraged it together, I believe, up in Yorkshire one time. Yeah, great mushroom, one that all foragers should know about. And it's a mushroom that's also reputedly able to take in airborne pollutants. So we're always advising people not to pick that one from the sides of roads. But a few years ago, when we were training up our instructors, our new instructors, one of them, Mr. Phil Leng, who's still with us today, he asked a really good question that got me thinking, which was how far away from the road should we consider safe for these mushrooms to be edible, considering what you're telling us? And my answer at the time was a little bit loose, a little bit fluffy, in that I like to have a natural barrier, like a hedgerow or a bank or something like that between the road and where I'm picking my mushrooms. But around here, there's loads of open fields and no natural barriers. And one beside my house, we were in it at the time, that has field mushrooms in a good year, not like at the moment where we're in a heat wave and the driest summer since the year I was born, by the way, 1976. Around here, at this time of year, we'd be expecting the field next door to be covered in field mushrooms, and there's no natural barrier between them and the road whatsoever. And last year, I collected up some mushrooms at different intervals from that road and sent them to use in your lovely laboratory there. And I also collected a sample from the centre of Hereford, near to where I live, the busiest place that I live, right beside what I think is probably the busiest road in Hereford. And it has commercial traffic and a traffic jam every rush hour. So it's a pretty busy road. It is in Hereford, not Peckham or somewhere like that. So, it's slightly different. But Giles, you look like you've... Oh dear, have I lost connection with you?
No, I think it's come back, hopefully. Is that better now?
No, you're not moving on the screen.
Am I not moving?
No.
Does that come back now? Oh dear. Can you hear me?
I can hear you, yeah. I just, you've stalled. Oh, there, you're back. But you'd stalled on a particularly odd face, so it wouldn't have looked good to have you on that for about, it was something like that. It threw me. I should have just kept talking though. Anyway, so there will be a few technical glitches here, everyone. We've never at Wild Food UK tried to do a Zoom interview before. We're no Joe Rogan, so forgive us, but the info will be as useful as always. We're back with Giles, and I was just explaining I picked some mushrooms from the field next to my house, which they were all field mushrooms, all the same species, and they were growing at different intervals from quite a quiet rural A road, the A438, if anyone wants to know exactly where it is, that runs from Hereford out into Wales. And I also picked a sample from right beside the busiest road in Hereford, the A49, where there's commercial traffic and traffic jams almost all day. So a very busy road for any airborne pollutants that come from cars. And Giles also went to the trouble of buying a shop-bought mushroom just so that we've got a sort of control for the experiment as well. And Giles can now explain what he did to those mushrooms.
Okay, so Marlo got in contact and I sent to him some specimen containers. So there were 50 milliliter sterile tubes, and with the instruction to just fill them with the mushroom samples and soil samples. So Marlo collected the mushroom samples from various locations, moving away from the road, put them in the containers, and then collected soil from the same location. So that was very important, because then we have we know, well, we can make some assumptions and some comparisons, if you like, to see if it's the substrate or the material which the mushrooms are grown on, it to see if that's actually affecting the composition of the mushroom in terms of the heavy metal toxicity. So I received all the samples back, and I basically dried everything down because there's obviously there's water in the mushrooms, and some of the mushrooms may have been a bit drier or a bit wetter than others, and same with the soil. But if we dry everything so everything is completely dry, then everything is basically, we're treating everything the same, which is very important if we want to compare samples from different locations. So now I had all the soil dry, all of the mushrooms dried, and and then basically ground up all the soil, and then accurately weighed out 0.1 of a gram of each soil sample into a microwave digestion vessel, and then also weighed out about 0.1 of a gram of each mushroom sample and put those into microwave digestion vessels as well. Now,
basically, you normalized all the samples there so that everything that you were doing was going to give you a result that could be, compared to the others. Yes.
I mean, the weights were slightly different, but I wrote down the exact weights, and then I made a correction factor according to what the weights were. So yes, all of the weights were normalized so that we could back calculate the concentrations accordingly.
Mm-hmm.
Then with each sample, I added 5 milliliters of concentrated nitric acid. So this is about 65% nitric acid. And then put it into close the vessel off. So these are microwave pressure vessels. They go into a microwave digester, and I ran them on full power for about 2 hours. And what that does, the vessels they're pressure vessels, so the pressure increases. I'm not sure exactly what the pressure was, but the temperature was maintained at 200 degrees C. Basically, anything that's in there is going to get dissolved and digested into that acid. Mm-hmm. So now we've got basically all the soil dissolved in the acid and all the mushrooms. Well, every sample is dissolved in acid. Mm-hmm. Once that's all cooled down, then made that up to 100 milliliters in a volumetric flask. So everything, essentially that 0.1 of a gram was digested and then dissolved into 100 milliliters of water. I made it so that the final concentration of the acid in this water was 2%. Okay, so the final concentration in the volumetric flask was 2% nitric acid.
So what we're saying basically is that it was very precise by the time you'd finished all of these processes.
Very precise. Yeah. And then once I'd had all the samples, everything was nicely dissolved. I then filtered off just to make sure there wasn't any particulates in there, but the digestion method we used would not have dissolved any silicon, okay, because we just used nitric acid. I didn't actually see any silicon particulates in there, but we don't really want any particulates going into our mass spectrometer. So the samples were filtered, and then they were ready for analysis with the mass spec.
Okay, so tell me a little bit about that then, because I know what spectroscopy is. I'm quite a keen sort of amateur astronomer, I suppose. So I've heard of spectroscopy, and I understand the science behind that. But tell me what spectrometry is.
Well, here, this is the mass spectrometer, or very similar to the one we used. So on the left hand, on the side here, we have the auto sampler. The samples were put in little tubes like this. So it just looks like water, but it's in 2% nitric acid. We then have a little pump here, a peristaltic pump, which sucks in the solution, and it sprays it through this spray chamber here. And we're making a fine mist. So we're making a mist, and then that mist goes into an argon plasma. So we have an argon plasma, which is almost, it can go up to about 10,000 degrees Celsius. So very, very hot. Okay. So any water that's in there evaporates immediately. And because there's so much temperature, any metals which have come out of solution are going to instantaneously ionize. So we're basically creating molecular ions in the gas phase. And what's an ion is, it's basically, it's the atom which has now lost an electron and it's become a positively charged ion. So if you have an ion, you can move it around with a magnetic field or an electrostatic field.
Mhm.
All of those ions get sucked into the mass spectrometer, and we have a quadrupole mass analyzer in the mass spec. And what that does, it separates the ions out according to their mass to charge ratio. So every ion has a mass of 1. Sorry, no, say that again. Every ion has a charge of 1. Okay, so they've all got 1 charge on. So the mass to charge ratio is essentially the same as the mass.
Okay.
And the mass is what you see on the periodic table. So different mass, it's basically you're adding up all the protons and the neutrons.
Mm-hmm. Right. Okay. Now I'm confused. I'm glad there's people with brains the size of yours that can actually do these wonderful things, and I'm sure that everyone watching is as well. So, really, to summarise, what you've done is you've totally normalised the samples that I've given you, so that they're something that we can compare. And then you've mixed them up in some fancy solutions, turned them into a gas, mixed them with a plasma, which, as far as I know, makes that about as hot as the surface of our sun. That's a bit of plasma that we see every day, isn't it? Maybe argon plasma is a little bit less hot.
Not quite that hot, but it's pretty hot. Yeah.
Okay, and then that sample is something that you can use to judge the elements that are present there, the metallic elements, or rather what scientists call metallic elements, which is anything after helium and hydrogen, I believe.
Yeah, so, I'll show you the periodic table in a sec, but essentially what the plasma does, it strips off an electron. So we're removing an electron and we're generating a positive ion. Okay, so that's what we're doing with the argon plasma. And then the mass spectrometer will separate out their ions according to their mass.
Okay.
And different elements have a different mass. Okay. Mm-hmm. But I think it might be a bit easier if we talk about the elements under investigation. If I show you a periodic table, which was one of the best discoveries in science by Mendeleev, a Russian. So it's a discovery, and it's a logical way of laying out all of the elements. And I'm quite sure if we met some aliens, they would have the same periodic table, and we'd be able to communicate with them in the same way as we could communicate them using mathematics. You know, it's a universal language, which is quite fascinating.
Yes, certainly is. Now, what we'll do is you can open up your PowerPoint presentation where we get to that periodic table. In the meantime, I'm just going to show people the sort of mushrooms that we did the experiment on. So this is the field mushroom, which, as you can see, it's a beautiful little agaricus species of mushroom. This is Agaricus campestris, and it looks very much like the mushrooms that you buy in the shops. And that's because it's in exactly the same genus as those mushrooms, your closed cup mushrooms and button mushrooms, portobello mushrooms. They are all related to this mushroom. And there's quite a few in the UK that are lovely and edible. So we've got the field mushroom that you see there. And then we've got the horse mushroom, which, as you can see, is a much larger version of the field mushroom, really. Doesn't tend to grow as prolifically, but it's a very tasty member of the family, of the genus. And then I'll move on to the only really... Well, one of the few toxic members of the family in the UK. We've got the yellow stainer here, Agaricus xanthodermus, and as you can see, it stains yellow when damaged. If you get that on one of your Agaricus species of mushrooms, then don't eat it. And here's another one that's a slightly different colouring. I've got the prince here, which is one of my favourites, up there with the horse mushroom in this genus. And it's a mushroom, again, that you can quite often see beside roads, as with all members of, or most members of this genus. So it's the genus that we've focused on here, the field mushroom, which is probably the most foraged for mushroom in the UK. That's one of the few limitations of this experiment, is that we're focusing on one species. We don't know how other species or genus or genre or families of mushrooms take in pollution in or how they do it in comparison to this genus. But we'll flick over now to Giles's periodic table, and we'll show you the elements that we've focused on for the purposes of this experiment. You need to share your screen now, Giles.
Yep. Okay. Right. So can you see the periodic table?
I certainly can. Yeah, familiar to
Excellent.
me.
Okay. Well, I'll just show you briefly as we move across the periodic table. God, I'm having trouble saying that word. When we go from hydrogen, helium, lithium, beryllium, boron, we're basically, all we're doing is we're adding a proton to the nucleus. Mm-hmm. So the number of protons defines what element it is. Okay. So hydrogen has 1 proton, helium has 2, etc. The elements we're going to be focusing on are, bear with me one sec. A couple of elements which are found in catalytic converters of cars. So I thought that would be quite interesting to look at. So we've got palladium and platinum. So they're used to essentially catalyze a reaction of any obnoxious gases found in the car exhaust and render them down to a more inert form, which is better for releasing to the environment. So we have platinum, palladium. We also have iron, so that's a ubiquitous element found very high abundance in the Earth's crust. Lead, I mean, this is an obvious nasty. We don't really like lead. It was used in fuels until I believe it was the 1980s in this country. It's not allowed to be used anymore, but it's obviously it's got toxic issues. And then we move on to the final one, which is uranium, which obviously has implications for the Herefordshire area, as quite high concentrations of uranium been found in that area.
Right. Okay.
So those are the 5 elements we're going to be concentrating on. But I think there's going to be an article on the World Foods UK website, which basically we can put the full data on there.
Yeah, we'll do that. Yeah. We'll publish everything that we've had as results for people to analyse for themselves. But we're focusing on these. Obviously, iron, that's actually something that you could consider nutritious. We all need iron, so that's not such a bad thing. So a little bit of a control in the experiment. Platinum and palladium, very expensive elements there. And who knows, maybe one day we'll be refining mushrooms to scratch out the last bit of palladium on the planet. And uranium, the big shocker to me, we'll get onto that one last. So yeah, let's have a look. How does the iron content stack up?
Well, I think, the first one, we'll look at the palladium and the platinum first. So there's two graphs here. The one on the left is what the concentration found in the actual mushrooms. So the very high level that was found in the mushroom picked in the centre of Hereford on the A49. So that one is concentration is just over 4 parts per billion. I mean, it's not poisonous at that level, but it's still quite a high level compared to the other mushrooms. And there's definitely a general trend of the concentration going down as the mushrooms are picked further away from that.
That's the red star at the top left. The x-axis there is the vertical axis rather is the concentration, and then the distance from the road we're measuring off to the right. And that green star there that's the shop bought mushroom.
Yeah, so that's the supermarket mushroom.
Okay. Yeah,
so that's slightly higher level, but it's nowhere near a danger level. I mean, this element, I don't think it's certainly not toxic at these levels, so I wouldn't be worried about that. But
just to explain what's happening here, it's come down obviously massively from the city centre to the very first mushroom that I picked by a country A road. So the city centre, and we'll see this in every graph, won't we? Is
Pretty much
higher in the elements that we're examining here than out in the countryside.
But if we compare if we look at the palladium found in the soil, it doesn't exactly follow that trend. So maybe the palladium is not being taken from the substrates. Maybe it's being absorbed from the actual from the air.
The trends being totally different, that kind of points to that, doesn't it? So if we see lines that don't correlate in these two graphs, it means that it's more likely, or we can assume that the pollution is getting into the mushroom from airborne particulates rather than from the soil, from the mushroom taking it up from the soil through its mycelium. And that's what we see here. Yeah.
So if we move on to the next one, platinum. Again, we see a definite reduction in platinum concentration. I mean, we were looking at very, very low levels here, less than 1 part per billion. But there's still, I mean, this instrument here, just to give you an idea of the sensitivity, will go down to parts per trillion.
Right.
So that would be like detecting, I hope I get this right. I think it's like 1 drop in 200 Olympic swimming pools. Right. It's either 200 or 20, but I'll look that up and we can put that on there. But it's very, very sensitive. It's
a 2 followed by some zeros. We're not quite sure how many.
A lot of zeros.
Either way, that's quite impressive. And this is what we're saying is that even in the one that's been picked from right beside the road, these aren't things that would have the World Health Organization jumping up and down with regards to toxicity.
No, it's okay.
Right.
Okay, so we'll move on to the next one.
But again, this one, go back to platinum a second, just because there's the disparity between the soil trend and the trend in the actual mushroom. What we can see is that this is likely to have come from airborne pollution. So again, it's something that probably, as you say, comes from catalytic converters. And what's interesting there is that the shop-bought mushroom in both of these graphs had pretty similar levels to most of the mushrooms that we took from the fields around here. So
yes, there's no major difference there with the shop-bought mushroom at all. No.
Right. Okay.
So if we move on to iron. So iron is, it's found in very high concentrations in the soil anyway. If you look at the concentrations on the soil graph, for example, in the city centre, we're looking at 35,000 parts per million, which is very high. So if we compare that to the concentration of the platinum found in the soil, it's 0.03 parts per million, which is tiny. So there's no point mining platinum in the centre of Hereford.
No,
you're not really going to.
That's a shame.
No, that's a shame. But there's certainly a high level of iron. But you find that in the Earth's crust everywhere. Certain areas are going to be higher than others.
I mean, we're not toxicologists, but at what level would that become sort of like toxic or worrying, or is there
there is a level, but I think you can eat quite a lot of iron. I think your body can deal with it.
It needs it as well. So
it's an essential mineral. Yeah, it's an essential element. We need it. Yep, of course. I'm not sure of the exact lethal dose, but we could look that up and maybe
I could maybe drop it in over the top of what we're saying here. Okay.
Okay, so there's the iron, and again the shop-borne mushroom. It's not as good as the mushrooms that were picked the furthest distance from the rural road. And at this level of concentration in the mushrooms, it's good for you. It's not bad. Okay, so it's not a lethal dose by any.
So mushrooms are a source of iron.
Yes, well, who'd have thought it? Yeah, we like mushrooms. Right, lead. Okay, lead isn't so good. We've all heard shock and horror stories about lead. So if we look at the lead in the mushrooms, it's going up to 10 parts per billion in the mushrooms that were sampled in the centre of Hereford. So that's quite high level, really, much higher than the shop-borne port mushroom.
Mm-hmm.
Again, I'm just trying to think what the level is. I know that the level, the health limit for lead is 10 parts per billion in water, but I think for food, it's actually a bit higher than that. It might well be 50 parts per billion. Mm-hmm. Again, we could look that up and flash that up, just so we've got a handle on that. But the interesting thing about this graph is there does seem to be a bit of a correlation between the lead found in the soil and the lead found in the mushrooms. So the samples, the mushroom samples picked at 70 meters, there's a slight elevation in the lead concentration in the soil, and that was reflected in the mushrooms. Mm-hmm. So it could well be that we've got some, some of that lead from the substrate is being sucked up. Because I know mushrooms have been used for bioremediation projects in the past, mm-hmm. And they can be quite selective to certain elements.
Mm-hmm. Right. Okay. Well, so it's a bit of a correlation. There are a few wobbly bits there, but you would expect that if they are taking in lead, there shouldn't be so much airborne lead nowadays, because obviously, as you say, it's not used in petrol. So if they are taking in lead, then they're taking it in from whatever substrate they're growing from. And that is quite a high level that we've got from the city centre mushrooms in Hereford there. But the mushroom picked 3 meters from the little A road on the outskirts of Hereford, that's actually got the same levels of lead as the mushrooms that you buy in the shops. So
it's worth noting, just with these graphs, so the concentrations for the mushrooms in each case, that's expressed in parts per billion, and I've worked that out for as if the mushroom was wet. Okay, so there's a conversion factor because I think the mushrooms have a very high percentage of water. So I've just basically worked, back calculated the results to express that concentration as if it was in the wet mushroom. Okay. And also, when I prepared the mushrooms, I made sure there was no obvious soil that was present on the mushroom as well, so they were clean.
Okay.
The soil samples, all of those, the concentrations are expressed in parts per million. So it's 1,000 times, the scale is 1,000 times higher. Okay.
Right. Okay.
Just so that you're aware of that. Okay.
Okay. But still the same, we expect the pollutants here, the lead, that's probably influenced by the soil or the substrate that it's growing out of, be it the wet or dry sample. Mushrooms can take in lead from their surrounding environment. Yeah. It's not a good thing, not a good property of our fungal friends. No. Let's have a look at the last one then, the big shocker for me.
Okay. So this is the uranium. Okay, so this is it's a heavy metal. So this is uranium-238. It wasn't any sort of depleted uranium or anything like that. It's naturally occurring. I wouldn't be worried about. I mean, it's slightly radioactive, but I'm not worried about that. The thing with uranium is it is highly toxic. Okay, so it's a very toxic heavy metal. The concentrations found, you can see there's a definite correlation in the mushrooms where the concentration drops quite significantly from the centre of Hereford to the ones picked close to the rural road. I'd say there's a definite correlation there. And if we look at the soil, it doesn't look like there's any direct correlation with the soil concentrations. So maybe this is airborne uranium, which you're all breathing in Hereford, which is which the mushrooms are then taking in through their skin.
So how does uranium get airborne, Giles?
It's dust, I suppose. That's the only way I mean, it's not going to be in a gas form. It's just going to be as dust, very fine soil particles.
So this is kicked up from the roads. By the looks of it, it does certainly look like there's a trend of the distance from the road being less radioactive, if you like.
Yeah.
Whereas the soil seems to be a lot more random. We're talking about airborne uranium being kicked up by the roads around here. Now, just again, obviously these are tiny, tiny bits, as you say, a drop in a swimming pool. But is there any way we could possibly quantify this for the people watching? So how would you compare, say, that mushroom picked beside B&Q in Hereford to, let's say, an X-ray or something like that?
An X-ray, there's no comparison.
Right.
I mean, it's a different form of radiation for a start, but in terms of dose, I mean, you're dosing it's a different wavelength of photon. Okay, so you've got X-rays and gamma emissions from the uranium. So I suppose if you get bombarded with a lot of gamma, it's going to do you harm, but equally with X-rays, it's going to do you harm as well in different ways. So it's very hard for me to give you that information.
Okay, but you wouldn't expect anyone to suffer from radiation poisoning from eating a few of those mushrooms from the centre of Hereford. It's nothing like that. It wouldn't be like, having 3 or 4 X-rays in a week.
But I think the problem is the poisoning from the heavy metal itself, rather than the radiation dose that would kill you.
Okay.
So I think you would have basically bioaccumulation of the uranium in your body, and that heavy metal is going to be what would contribute to your ultimate demise.
And it's giving out gamma radiation the whole time it's in your body.
Yeah, but I don't think that's because the dose is so low. I don't think that's going to be an issue. It's going to be the actual
toxicity. I know you've said, yeah. And what anything about the symptoms of uranium poisoning? What sort of symptoms does the toxicity give you?
Well, I mean, the classic examples are all those birth defects in Iraq. So a lot of the ordnance that was fired on tanks and other bits of heavy armor, sometimes they use old nuclear waste, depleted uranium, basically on the tips of these rounds because they're armor piercing. And then that gets into the environment, and it causes horrific birth defects. I mean, obviously, it's going to be much higher concentrations than in Hereford. But I think that's ultimately what you get. I mean, you just get mutations, I would imagine.
Right. Okay. And uranium itself being in the air, and doesn't that turn into radon gas? Does that mean we've got radon gas flying around Herefordshire as well?
Yes. So that's one of the nuclear decay products. So radon gas is quite heavy. So if you have a basement, you can have high concentrations of radon found in the basement. So uranium is found in granite. So if you've got a lot of granite in your area, that's a naturally occurring rock, which is got quite high concentrations of uranium in it. Okay.
All right. Well, I suppose the big question to ask on this is whether you would consider eating the mushrooms picked from beside the road in Hereford.
That's a big question. I think what we'll do, I think I'd give them a wash. Definitely, I'd give them a wash to start with. But the elements we've discussed today, as far as I'm concerned, there doesn't seem to be anything that's too high a concentration.
And then outside of Hereford, outside of the really busy road, though, as soon as we got 3 meters away from the A road, which does have lorries and cars driving along it all day, but it's not a busy A road. As soon as we got 3 meters away from that road, it looked like for most of the elements, they more than halved. There was like less than a third in some of them. So would you consider the ones from beside our country A road out here, based on what we've analysed so far, would you consider them safe levels?
I think they're all safe. Yeah.
Yeah.
I mean, what we'll do, we'll flash up the guidelines, the health guidelines. But from my memory, I mean, if you look at the shop bought mushroom, it's fairly close with all of them. I mean, we didn't find
the only
any
thing that the shop bought mushroom didn't have was the uranium, funnily enough, wasn't it?
There was no
Similar
uranium
levels of lead. So I think an assumption can be made that when you get out of city centres, when you get out of real heavy traffic, most of the mushrooms that you're going to be picking are going to be safe from an airborne pollutant point of view.
Yeah.
So country roads, you're probably okay. If you can, though, pick from further away. And it's, you know, as you pointed out to me when we were talking about this, everything's a sort of product of its environment. And, you know, if you're going to go foraging in a clean environment, and you're going to get clean, healthy, unpolluted foraged fare. If you're foraging from a city centre, then you're likely to be eating the pollutants that are in the air there. So it might be worth expanding this experiment, I suppose, into plants and other things that I know people pick from more urban areas. And there's also a few other limitations that we've had to this experiment. I've already mentioned that we've only focused on one species of mushroom, and we're sort of assuming that other members of that genus will probably show similar results, but other different types of mushrooms have completely different makeup. So they might not take in the airborne pollutants, and they might take in more from the soils. I do know that the amethyst deceiver is known to take in arsenic from places where that's found in the soil. So that's something that I might put to the test with you at some point. But for everyone watching this, if they're interested, are you and your company available to get to do this for the general public? You know, maybe we could turn this into a slightly paid for you citizen science project, maybe, where we analyse things from around the country. Can you?
That would be very interesting. So at the moment, we're doing home water testing. So we have a website called The Water Professor. So we're doing home water testing services.
I'll bring that up now.
Yeah, so we're basically going to roll out some new products for soil testing. So this would be a useful, there's a lot of allotments which may well have been built on a previous, well, I would hope not a brownfield site, but there have been cases. Well, I think you have a story about that, don't you?
Yeah. When I lived in Croydon, I had a vegetable patch in my garden in South Croydon, and I never quite got the full report, but the Environment Agency came and tested the soil and condemned my vegetable patch, told me in a letter, which I don't still have, unfortunately, that I shouldn't grow or eat any more vegetables from that vegetable patch. And that if any children had eaten things from my vegetable patch, they should go to the doctors.
It's pretty harsh.
Yes, it was. We were in one of the lowest lying areas of borough of Croydon, though. So, and I assume these heavy metals, lead in particular, they're going to over the years sort of work their way down to the lowest parts of any area because they're heavy. That's why I've always been a little bit weird, everyone. I've been lead poisoned in the 80s and 90s.
So in answer to my question from the beginning of the video, am I going to pick these mushrooms and take them home and put them in my pot? The answer is actually no. But for reasons I'll tell you, somewhere a little bit more quiet. beauty. So why wasn't I picking the ones from beside that road? Really, in all honesty, because I just don't have to. I've got this whole field to pick from that's further away from the road, and there's loads of these mushrooms around. But in reality, what the results showed was that the mushrooms from the city centre, a much more busy road, if you like, those mushrooms certainly are ones that I would leave behind personally. I know Giles said that giving them a wash and eating them might be okay, but having seen the full results of all of the metals that were present in the one beside the road in the city centre, I'd leave the city centre ones behind. And the one beside the road there is still going to have just a tiny bit, a very, very tiny bit. We were talking parts per billion, I think, with the uranium, but I don't want any uranium in the mushrooms that I eat. So what we found was that as soon as you got more than 3 meters away from the A road, the mushrooms were just a lot less full of any of the airborne pollutants that were coming from the road. I still prefer to pick from the other side of a hedge if possible, but that seems to be a safe distance around here. But we also saw that mushrooms were taking in pollutants from the soil as well. So the rule is really try and pick from clean environments. That way you know you're going to get foraged fare that is nice and clean and healthy. I do hope you've enjoyed this video, and if you do live in Herefordshire, don't worry too much about the uranium. It's in very, very, very tiny quantities, but it is there. It's something to be aware of. I hope you've put up with all the sciencey stuff, and I hope you've enjoyed this video. I'm going to do more of my normal videos over the rest of autumn, and this experiment that we've done, I hope that you guys do take up my little offer of a citizen science project, because I'd love to know a sort of map of where mushrooms are potentially more polluted. They're a marker of pollution in the environment, so it will be useful to know those things. So do get in touch with Giles through artemisanalytical.com, artemis-analytical.com, and their water testing site, thewaterprofessor.com, I believe it was. The links are in the description below anyway. And so are some links to the entire results of the experiment that we've done. So I'm going to leave the ones by the road, and I'm going to take this little beauty home, and me and Bonnie and Attila are going to have mushroom chow mein. Should we do that today, Attila?
Yeah, sure.
Let's do that then. Okay, that's me signing off for today, and I'll be releasing some more videos soon. If you want to find out more about what we do, go to www.wildfooduk.com.